Hey everybody, I'm Cory, as Simon said. So my job title is I'm a principal systems engineer for EMC, which just means I'm a big geek. And then they asked me to run a program within EMC called Data Fabrics, which really the goal was to help our pre-sales engineers, both inside EMC as well as our partner organization, better understand the technologies that are driving big data analytics in this IoT ecosystem. And Splunk is obviously a really interesting partner for us and a really interesting platform that our team needs to know about. So I was kind of, if anybody were in the South, so I can use country music references, I was the Bartley and Drell of Splunk at EMC, or Splunk before Splunk was cool. Country before. Okay. So anyways, I was the guy that was like telling everybody Splunk was awesome at EMC, and they were like, look, hush, we're not really focused on that right now. Let's talk about SAP, and then all of a sudden Splunk is becoming critical and awesome, and now I think I may have been onto something, which is awesome. So here's the general trends we're seeing from a Splunk perspective that have driven EMC to really invest not only in our knowledge and our skills around Splunk, I'll talk about some of those investments, but really just trying to help our customers solve some really interesting challenges. So Splunk is no longer just this little log tool that sits in the corner. It has become an absolute critical part of many of our organization, our customers' IT platforms and strategies, which means as applications become critical, things start to happen. One, as adoption and the sources continue to grow, the size of these environments grow very rapidly. Not only from an ingest rate perspective, but a retention perspective, because a lot of the data that customers are starting to use Splunk to index may fall under regulatory compliance retention reasons, right? There may be some security reasons why they keep more data. Splunk search performance is becoming all that more important as it begins to creep into the spaces of operational intelligence that have traditionally been owned by databases, database tools. Performance is really critical. We're also seeing high availability and resiliency needs to go beyond just what the application can provide, but actually leverage infrastructure reliability and availability services. And then we're starting now as a lot of customers, when they started with Splunk, and you guys have probably deployed it, where it's really its own silo, it kind of sits outside of IT's purview, maybe running on a dude's laptop, and then it kind of grows. But as it grows, it becomes under the domain of enterprise IT, which means certain enterprise IT processes and design paradigms get applied to it. Things like virtualization, shared storage, and others, and that's becoming very, very common. And then efficiency at scale is becoming a really interesting concern. Like any of the big data applications ecosystems, think Hadoop, think Splunk. As I index more data and I put more data here, the scale problem, how much space is taken by data center to keep petabytes of data potentially. So those are becoming very interesting, and EMC is absolutely committed to providing our customers with scalable and efficient solutions for Splunk. And we're working very closely with Splunk to make sure that those statements are true and reliable for you. So you guys probably know EMC is a storage company, right? Probably heard that before. And storage traditionally was most storage platforms, if you know EMC, like VMAX and DNX and some of the older platforms, they're what we refer to as scale up, meaning they've got a finite number of controllers, right? The storage servers, if you will, and then they've got trays of drives behind them. And to get to a large capacity, oftentimes you have to build up lots and lots of them. You may have 20 or 30 arrays in an environment to meet a petabyte capacity. That's what we call scale up. And that's not aligned to how Splunk is designed, right? Splunk is designed to go from desktop to enterprise and thousands of machines, and it's to be able to scale linearly. Well, EMC has adopted a very similar design paradigm in a number of our storage platforms to meet the needs of these growing applications. So we have these platforms now that we refer to as scale out. And we're going to talk about a few of them today, but think about it this way. They are storage platforms that have a design paradigm that's similar to Splunk in that they start small, right? Small number of nodes, to go to either hundreds or thousands of nodes at scale linearly. Okay? That's just the general design paradigm. Certainly EMC platforms, our legacy ones, can do good things for Splunk, but the reality is that what we're talking about with customers going to look at large-scale deployments, we like to position those scale-out storage platforms for scale-out applications. All right? Okay, so we all know that, most of us should know that Splunk indexes and it uses these buckets to tier the data, either based on age or size of the bucket. So hot and warm are the home path, right? And typically, with your home path, as we heard from Deep and Dritan about, you really want to use high-performance, low-latency storage, right? SAN with flash or even local flash is really interesting for accelerating that hot and warm. And 98% of the searches come from that data that's less than 7 days old. This is a great opportunity to invest in flash technologies, right? Everybody like that? That's good. We like that. We agree. Now, on the cold side, you're trying to optimize your cost per terabyte. This is where your longer-term retention comes in, and you really don't want to be paying maybe the cost per terabyte of flash. You really want to look at some technologies that have a more attractive, there's apparently a timing on this, and it's bothering me. So you want to use technologies that have more attractive cost per terabyte. Splunk allows you to use not only your traditional DAS for cold, you could also use a SAN for cold, but also allows you to use NAS or using NFS-based storage, which typically NAS technologies are much more attractive from a cost per terabyte than SAN or DAS. Okay? And then frozen is the concept of I have data, I have to keep it for some reason, but I'm not going to do a query it, which we kind of think we understand why you do that from a cost, right? Get it out of band. But there's a lot of reasons why customers may want that data in their cold environment so they can actually derive value from it. Okay, so customers often ask, you guys asked me the whole session about it, how do you derive the storage calculation for Splunk? Like how much storage does it actually take to run a Splunk environment? And as we learned, there are basically two kind of main levers to pull in terms of sizing. There's the ingest volume, and then there's the retention period. And there's some other things we'll talk about in our clustering, but those are the two you have to know. So let's take an example. Let's say I got a terabyte ingest per day of log data, and I'm in a distributed environment. That's going to write two sets of data as it indexes the data. You're going to have the raw data files, and you're going to have the indexes, right? The raw data files, highly compressed, they're really the small amount of what gets put on disk. But the uncompressed indexes are where all the good GUI bits are that Splunk's going to take advantage of to bring the value that you expect from Splunk, right? And that actually consumes more of the space that's actually through the disk. Through the compression process and the way it's written, we typically see that the amount written to disk is roughly half, right? It's a good estimation, roughly half of what the index volume is, okay? And that's assuming, again, that I'm in a distributed deployment, not doing index or clustering. So, again, as we try to figure out how much storage we need, we take that ingest rate times a half, which tells us how much is going to be written to disk in a day, times the retention period, right? Not too hard to figure out, it's not crazy math. So a terabyte a day, at 60 days retention, let's say, that's 30 terabytes of storage. So that may be your total retention, but you can use the same calculation to get a rough estimate of your hot and warm retention and your cold retention as well. Okay? Does everybody agree with that? Make sense? All right, so we have got the amount of storage. Now, if you do turn on indexer clustering within a site, we talked about it yesterday, right, that it does create copies of data. So that's going to increase the storage consumption in a pretty predictable fashion, right? If I turn my search factor, which again manages the number of copies of the indexes, and replication factor manages the number of copies of the raw data files I keep. If I turn that up to say, let's say 2 on both accounts, it basically doubles my storage footprint. I know the math is incredibly challenging. I didn't realize you were getting an algebra lesson, right? So times 2, it doubles. Times 3, it triples, right? That has a real impact on underlying storage infrastructure. And that's part of the reason why storage people love to talk about Splunk, because it starts to add up very quickly. Now, you don't have to be a big Splunk customer, or you don't have to be helping a customer deploy a large Splunk environment to end up in petabyte scale problems. And petabyte is a word that it's in our vernacular now, it's very common, but for many years that was, the last few years, that was kind of like a crazy idea. But look at this. This chart, let me explain what it's showing to you. It's basically showing on the left-hand side here, it's showing you an index in terms of gigabytes per day. And on the top, it's the amount of retention period that you might have, okay? And I think the projector, you can see, if there's some that are shaded in, that's basically where we get over the 100 terabyte range. So again, if you are doing a terabyte a day, your retention only has to be 6 months, and you're already north of 100 terabytes of storage. Again, assuming that you're doing a rep factor and search factor of 2, okay? But even if you're a terabyte a day customer, you can end up having over a petabyte of storage required to meet your retention needs. And a petabyte's pretty scary. And the question I always ask is, okay, if you're going to need a petabyte of data, do you really want to buy all the servers using direct attached storage that you would need to get there? Like if every server basically has 10 terabytes, let's say, do you really want to manage enough servers to get to a petabyte of that density? Probably not. This is the value of decoupling compute from storage, specifically in the cold. It's like a no-brainer. But even in the shared storage space for hot and warm, it starts to get really interesting. So we start to see that 100 terabytes is kind of the area where it starts to make sense to not only decouple compute from storage, but also potentially use 2 different platforms of shared storage for an environment. So you have a big NAS and some sort of SAN or flash-based technology for your hot. Okay, so let's talk about some of those. EMC's value proposition is exactly that. If you want to decouple the compute from storage and use a shared storage that's aligned to our similar design paradigms as other enterprise technologies, like we've been virtualizing and using shared storage for Oracle and SAP and SQL and lots of things for years, there's a chance to do it here as well if you design it correctly. So hot and warm, we typically position XtremIO, which is an all-flash SAN technology, really, really neat, or ScaleIO, which is a software-defined SAN that basically takes advantage of the existing drives that are in a server and virtualizes them and abstracts them away from the physical construct of that server and creates a virtualized SAN environment. So it's really kind of an interesting way to leverage existing SAN investments, but add some data services that don't exist in direct attached storage models. Okay, and then for cold or frozen, which we like to get away from frozen because we want you to actually derive value from all that data you're creating, we like to position Isilon. Isilon is a scale-out NAS, and we'll talk about the detail. But the point here is this model of using shared storage for hot and warm, decoupling compute from storage, allows you to scale the component of infrastructure that you actually need to solve the problem. So if you're having, we heard yesterday, if you're having a search performance problem, what's the first thing you add? An indexer, right? And an indexer, you're adding it for one of a couple reasons. Either you're CPU and memory bound on some jobs, or maybe it's I/O bound. So if you're I/O bound, why would you add another indexer when you could just add more storage? Start to get the idea, right? Pick the component of the infrastructure instead of being the only answer is add another server with all these drives in it that you may or may not derive value from across the board. Kind of smells like the story that got VMware to be like that giant company, right? Remember everybody was deploying when client server came out and they had all these servers running at 2%, 3% utilization, and VMware came in and said, you know what, if we virtualize all that stuff, put it on a shared infrastructure, you get a lot more value out of your investment and you could pick the component and infrastructure to solve the problem you have at the time. Fast forward, here we are, okay? So now some of the data services that get really interesting are things like deduplication. So XtremIO, for example, does deduplication inline, which means that the overhead of those additional copies for indexer clustering can be canceled out, meaning that you're not consuming the additional storage by moving to a rep factor or search factor of 2 or 3. It's actually canceling out that underlying overhead. Kind of interesting. So the other technologies do a little bit of that, not to the same level. So we don't assume it in some of our calculations, but it does have some real savings for our customers. And then there's things like, if you're deploying Splunk in a highly regulated environment, there's probably a chance somebody wants the data encrypted at rest. That's becoming a very common thing for a lot of customers in infrastructure. These platforms give you the ability to do that at the storage tier to meet that requirement. We also give you the ability to do things like snapshots, which are really an interesting way to protect things like the home path, so Hot Bucket. Hot Bucket's kind of a pain to back up because it's like a database. It's constantly being written to and read from. Okay? So those are really interesting data services that many customers ask for because, again, it's efficiency at scale and building the right component at the right time. So again, XtremIO, super fast. Right? If you're already using flash and servers, probably not any faster, but this is shared flash storage that does accelerate some of those I/O-bound search needs. So again, if you're doing searches that are I/O constricted, this is a really interesting platform. We can put, they're basically up to 40 terabytes in a brick today, but they scale to 16 bricks in a cluster. So again, you start with one, and if you find out, hey, we need more capacity, you just throw another brick in. They're connected via a back-end unmanaged network that you don't have to worry about, and it just scales, right? It's performance capacity scales linearly with no tuning, no rate setup, it's nothing like that for you. So super fast, and it does do the deduplication, which can save money. So the time we would talk about this, if customer wants to go faster, kind of interesting. And if customer is having a problem with the overhead associated with indexer clustering in a site, this can help alleviate some of those challenges, okay? Now, if you have a customer that's already doing, let's say, they've already been deployed on direct attached storage, and they really just want to add some additional data services without maybe completely changing their architecture, this is a really interesting story. So if you guys are familiar, everything like software is eating the world, right? So this is software-defined storage. The concept here is we take servers that have those drives in them, and they can have multiple types of drives. You could have servers that have disparate kinds of drives, and you run a software called ScaleIO, and it basically takes those drives and creates a SAN on all of them, and then shares the performance of that aggregate capacity to any particular indexer who might need it. So imagine if you have 10 indexers that have 10 drives in them, right? Each indexer only has access to the 10 drives that are in it. If you implement ScaleIO, now you have any particular indexer would have potentially the capability to leverage the horsepower of 100 drives. Right? That's kind of an interesting story. Again, you get to implement things like snapshots, and the deduplication is coming. So then Isilon is not for hot and warm, because it's a NAS, and you don't put hot and warm on NAS. It's generally a bad thing to do, because NAS have latency. But for cold, it's actually pretty awesome, because we get a really attractive cost per terabyte. And again, clustered scale-out technology, you can start with 3 nodes, which is only about 20 terabytes in usable capacity, and scale all the way to 68 petabytes in a single volume, single file system, single namespace. And it literally takes about 60 seconds to add a node, and the node automatically rebalances under the covers, and there's literally no configuration changes needed to go to Splunk or any other application to take advantage of that capacity. Very, very simple technology. It is the most widely deployed NAS today from EMC, and it is absolutely the fastest growing NAS in the market. We heard earlier from the Palo Alto guys, if you're in Gartner's Magic Quadrant, you love Gartner, we happen to love Gartner. Okay? So again, this does offer deduplication, so it can help and alleviate some of the overhead associated with those clustered indexes. Although we do know that in 6.4 there's some software-based data savings that are pretty cool. It just means that you get to store more stuff on Isilon. Okay? Now, it wouldn't be nice if we just said this stuff and we didn't actually go test it, improve, and have Splunk go out and help us understand, does this stuff actually work? Well, it turns out it does, and we work together to actually make sure that you, the partners who are delivering this stuff, and your customers, you actually have some faith that EMC and Splunk together have actually deployed these technologies, tested and made sure that they are interop very nicely and that they'll meet the performance requirements. Okay? These are, again, you'll get these slides. These are links to the reference architecture for both XtremIO and Isilon together, or ScaleIO and Isilon together. And again, I'll say this, just because we have this reference architecture doesn't mean it's the only thing that EMC will ever talk about. There may be cases for customers where we would only position ScaleIO, or we may only position XtremIO because they may not have that long-term potential. Or a customer may already be a VNX or VNX customer, and they may have capacity to use it there. It may be a good fit, but you want to work with us to make sure that we validate that configuration, and we don't do something that's going to cause harm to the application. Okay? Now, we package all this stuff in a really interesting model called converged infrastructure. And we've heard about cloud, right? Cloud's easy because you can spin it up and you don't have to manage it, and that's great. Well, EMC, about 6 years ago, started a company called VCE, and the goal was to give our customers a cloud-like operations model using on-premise technologies from the best-of-breed vendors in the world. So a vBlock is the first instantiation of converged infrastructure. Think of it this way. It's Cisco UCS servers, right, kind of awesome. Cisco switching, they kind of own that space. EMC storage, market share leader, and VMware is the orchestration layer on top. And by the way, it's also equally funded by Intel. So Intel obviously has a big investment with all of this, okay? So we package all that up in a single SKU, and it's a single model for support. So if you buy a vBlock, we can design it specifically for a Splunk implementation. Like if you have a large-scale Splunk implementation, you might buy a purpose-built vBlock. We can build it to the config to meet Splunk's requirements, and it's literally one number to call for support across the entire infrastructure. So if you have a VMware problem or storage problems, server, doesn't matter, one number. The entire thing's updated, just like the cloud, it's all updated together. Super simple model for consumption. Okay? So again, think of this as like a cloud-like appliance, and it's a packaging that really helps our customers accelerate their deployments and simplify infrastructure management. Cool? Okay, now EMC's also, like you've seen many of the other partners, we're investing in apps. So very excited, we have 2 apps that we initially launched that EMC actually funded and had built, which was the XtremIO and Isilon apps. These use the native APIs of each platform to pull performance and log data so that you can get a really nice introspection into those environments. Makes it easy if you have Splunk customers that happen to be running these technologies, whether or not they're actually using them for Splunk, you can Splunk them, right? That's kind of great. Now, we actually had a neat story where a Splunk SC in Brisbane, Australia, and an Isilon SC in Brisbane, Australia, which I kind of want to go live with them because it's beautiful, but they co-created this Isilon file system audit app. So as Dave was saying yesterday, Isilon has this common event enabler. It's an output for file system activities, and they actually integrated and built an app, and so it's available in Splunkbase. It gives you that really nice file system auditing. Who did what with what files when, right? That kind of detail. So very neat. And one of our other Australian SCs, which I've heard a lot of stories from Australia. Apparently they Splunk a lot more than we do. I don't know what's up. Anyways, then one of my guys on our team actually built a VNX app in TA. These are the links to the apps. I didn't put the TA links in there. You can find them. They're right there connected to it. So make sure you get those. They're really, really cool. And then we at EMC, we recognize that our pre-sales teams didn't have the depth of knowledge on Splunk to really accurately size and build infrastructure. So about a year ago, I got the pre-sales leadership team to fund building a team of 36 SCs around the globe. Literally, I have them in every theater that are deeply trained in Splunk. Most have been through SC1, many have been through SC2, some of them even through SC3. And we do boot camps, they've been through admin and architect. So these are folks that have day jobs as EMC SCs doing something else with some technology, but are Splunk subject matter experts in the field for you and your customers to leverage when they have questions about how to deploy EMC correctly, what platforms they should be considering. Now, we do use Splunk's best practices religiously, or at least we try to be good religious followers of the best practices, because we don't want to get in contention. That's one of the things that if a software vendor and a hardware vendor disagree on something, the software vendor almost always wins that argument, and for good reason. And so we don't ever want to give our customers or our partners heartburn over a recommendation. So we try really, really hard to align everything we do to basically what's Splunk do. And if there's ever a discontent or a mal thing going on in the field, call us and we'll absolutely help. And I'll give anybody my card that wants to. And then so I want you to know that we've got 36 ninjas. If you ever have questions, I can give you that list. There's a public list of who they are, but they're awesome. And we do focus on building these converged systems first because it does help solve some easy problems. And I didn't put it in here, but EMC is an alliance partner that we actually resell Splunk. So many customers who are large-scale EMC customers may not be Splunk customers. And as they start to look at acquiring Splunk, it gets nice for that customer because their purchasing department may not have to bring on an additional vendor. They can buy the Splunk licenses through EMC, simplifying the purchase process, which is great for Splunk because it accelerates the revenue generation, which is good. Okay, so many people ask, why is EMC actually partnering with Splunk? And I kind of think of it this way. There's a lot of stakeholders in technology and in who buys and uses these things. So first, for our customers, both Splunk and EMCs, our customers like and they benefit when two technology companies work together, right? When we integrate and we validate and improve technologies, it gives them comfort in deploying something new, which is good because there's a lot of EMC customers, there's a lot of Splunk customers. If we can bring the joint value that they find in those companies together, it's better for the customer. Partners get to focus less on worrying about infrastructure. If you've got a partner like EMC that can build infrastructure properly, you get to focus on the services and the deployment and the exciting value add things instead of designing the underlying infrastructure. We've done a lot of that work for you. And Splunk gets a nice story out of this. So because of their partnership with us, we're much larger than Splunk in terms of revenue, in terms of people. And EMC is known as a very powerful sales organization. We're very sales driven. Whether that's good or not, I don't know. But we are a big company and we do very good in sales. And our salespeople are now incentivized and they're compensated to go sell Splunk, which will help all of you who want to sell services associated with Splunk and implement these projects. There's more people out telling the story of the good news of Splunk, right? And then EMC is actually using Splunk technologies to get smarter, both within our product teams, within our own corporate IT, but also in our pre-sales teams to do cool things with Splunk, build demos, actually make the lives of our SEs easier. So funny story, we have a side project going on right now where we're actually starting to Splunk the call home data from a number of our platforms to start to build preventative maintenance programs that our pre-sales engineers can automatically start to send out proposals for upgrades or proposals for capacity additions if they start to pass certain thresholds. So we're just starting to get smarter with it. And obviously collaboration drives innovation. Two companies working together, they get to use some of our smart engineers, we get to learn from them, and so things innovate more quickly. So we're committed to your success, to our customer success, and to Splunk being successful in the market. Now, we've only officially been like the alliance partners for about 6 months, and we have learned an absolute ton. Now, the first thing you have to remember is that there is a lot of Splunk customers out there today that already run on EMC technologies, and a lot of them we didn't even know. It was actually quite enlightening to go in and, we queried our Salesforce and we said, okay, where did somebody say they sold something for EMC that they listed Splunk somewhere in the opportunity name? And we found like an uncanny amount of opportunities that none of us knew were actually going on. We found customers that had deployed our technologies, were super happy, and we didn't even know. We had no idea they were using it. The Splunk teams had never talked, so we're starting to get better together, and that's a really good thing for us. The other thing we're learning is that as the folks who are on the ground deploying Splunk, there's a lot of levers that you can pull that have massive impacts on how Splunk will affect infrastructure. And if you don't really take into account what those pull motions are, you can cause some pretty significant challenges for infrastructure providers and the customer who provides the infrastructure, right? You can create some challenges that then downstream will affect us. So my ask is if you start to look at EMC as a technology where you're saying, hey, this might be some good tech to roll Splunk out on, if you have questions or concerns, like holler at us and let us work together with you. Because just saying, well, we don't know if it's fast enough, so we'll jack up the retention on hot and warm, will clearly cause some pain somewhere. We don't account for it, right? And then the other thing, and this is probably the most salient point I want you to take away nothing from what I'm saying, and that's benchmarking can be weird. And we are in agreement that Bonnie++, although it is the standard kind of tool that most of the Splunk folks use to go kind of get a litmus on, is the infrastructure kind of up to snuff? Be careful because it is known that Bonnie++ doesn't accurately represent performance of shared infrastructure. And I can give you an example. We had a customer that was deploying Isilon for coal, and they were a little frustrated because the Bonnie++ numbers they were getting for coal were really high latencies, like measured in seconds, not milliseconds. And the customer got really concerned and pushed back and said, we can't use this. This is garbage. Why did you sell us this? And then Splunk and EMC got together, reran Bonnie++, changing some configurations that are known to help better emulate what real Splunk performance looks like on shared storage, and found that it was actually sub-millisecond latency, and it was really, really good. And it was literally just a benchmark problem. It wasn't accurately reflecting what Splunk would really look like using that technology. So just be careful with the benchmark testing, right? There's even things like, depending upon which version of Bonnie++ you get, you're going to get completely different numbers. So just be careful with it. If you're running, you're going to deploy Splunk on EMC, and you are at all concerned about performance, our ability to meet the general standards, please reach out to us, and we'll introduce Jenny's one of our the Splunk SEs assigned to work with EMC very closely, but we will absolutely jump to help you really validate and vet that the configuration is stable and will work. So just be careful with the benchmark. Don't hold it up and go, oh, your stuff sucks, and walk off, right? That doesn't help anybody. Okay, and then we collectively, like we, EMC, Splunk, we don't really know as much as we'd like to right now on the I/O profile of Splunk at scale in the shared storage context. And so EMC and Splunk are actually embarking on a really interesting project to do a massive data collection. So as I said in this first point, right, there's lots of Splunk customers running EMC under their Splunk. So we're actually going out and we're actually starting to collect data from those customers to build a profile of what Splunk at various levels using various configurations from a host perspective, from a virtualization perspective, storage perspective. What are the levers and infrastructure that really impact performance? And what does good look like across each of those kind of deployment models, the technologies, so that we can give even more metric-oriented feedback to you folks in the field on what should you deploy, what should the best practices be, and not only from an EMC perspective, but just general shared storage, we're going to gain quite a bit of insight. Okay, so that's ongoing. And then my asks of you, and we'll take questions. So my ask of you is, first of all, if you're in a project that somebody's talking about EMC, please reach out to me or get to know your local EMC Ninja. In the US, there's about 20 of them, so they're pretty nicely spread. There's probably one near your hometown. I'd love to introduce you to them, get to know them. They're smart, they're awesome, and they're really willing to help. Okay, so first of all, get to know your EMC Ninjas. Second of all, if you have accounts where EMC and Splunk are in together, encourage them to get us together. Right? Get the account teams from both sides to talk. We're already doing that at a macro level corporately, but if you as the partner, as a trusted advisor, have the opportunity to influence that, it's good for everybody. Okay, and then go check out the apps. They are pretty sweet. I'm not going to do a demo today just because we had it was a long story. You can demo them, they're pretty easy, and then definitely share those with your customer because that's a great value add for your customer that if they're already running EMC, which based on market share, there's a lot of customers running some EMC technologies, this is a good opportunity for them to Splunk in. By the way, if Splunk consumes index licenses, Splunk probably needs to sell more. Right? Okay. All right. So, and if you have a customer running Splunk on EMC, and we haven't already done a data collection in the last month, please reach out to me. I'd love to come in, talk with your customer, and do a data collection with them to really profile. And the get for them is we give them a full health check output of the environment, but it's good for us too because we get to anonymize and redact the data and really learn things from the performance data. And then keep being awesome. It's been a great week. I really appreciate the interactions we've had. And if there's anything I can do for you or EMC can ever do for you, feel free to reach out, okay? Thank you, guys.